Okay, welcome to the unit circle. So far we've been talking about how we can only deal with sine, cosine, tangent, SOHCAHTOA, our 30, 60, 90 triangles, our 45, 45, 90 triangles, only in right triangles. We're going to expand that view a little bit in that now we can take the sine and cosine of values bigger than 90, which would be impossible in a right triangle. We could take a sine of 300 degrees, okay, and we're going to just look at how closely related a circle is, especially this one unit circle, is with the sine, cosine, and tangent. Okay, so here's the picture of the unit circle. It's pretty straightforward. Okay, we draw it on a coordinate plane, so we've got the x-axis and the y-axis here. And we draw a unit circle, meaning a circle with radius 1. Okay. Now, the nice thing about this is if we take any point, there's a point already drawn here. So this point would be x, comma, y. Okay. Meaning we could draw a little right triangle here. Okay, straight down. Here's your right triangle, which would be from 0, 0 in the center. We would go right x, and we would go up y to get to our point x comma y, right? If our point was 4, 3, we went right 4 and up 3. Okay. So now off to the side, we can figure out what is the sine of this. Okay, so we can say of this angle here in the middle, this theta here, okay, of this theta, we could say sine of theta, I'm going to do it up here in the top right, we could say sine of theta is opposite over hypotenuse, y divided by 1. Now, of course, anything divided by 1 is just itself. So the sine of this angle in this unit circle is equal to y. So this y right here is the sine of theta. Interesting. So those are equal. Okay, totally equal. Right? We could do the same thing off to the left here. So the cosine of theta, just looking at this angle again right here, we would say the adjacent x over the hypotenuse 1 is x over 1. And so we get that the cosine of this angle, theta here, is equal to just x divided by 1, or x. So down here, x is cosine theta. So what this means is, as we take this point and we move it along the circle and draw right triangles, okay, we could put the point over here and draw a right triangle, okay, where our point x comma y, where this distance here is x and this height is y. We could even draw it down here below the x-axis, okay, where again we have some new, and just to be clear, I'll call this x1, y1, x2, y2. Okay, well, we're going to have that you can go back x2 and down y2. Okay, so as we move this point around the circle to any point on the circle, we could draw a little right triangle, and we could figure out that the coordinates for that point for xy are equal to, in parentheses, the cosine of theta, comma, sine theta. Okay, now there's a little caveat there that if we're drawing right triangles, we're dealing with just distances or lengths of the sides of the right triangle, and the points x comma y will actually possibly be negative x, like negative 2, instead of just a length of 2. So we'll deal with the positives and negatives later. Okay, but the basic idea is, by moving this point around the circle, the whole time, the x value is just the cosine of your angle, which is some decimal between 0 and 1. Right? And then we have the y is the sine of the angle. And again, it's just some decimal less than 1. All right? So let's go on. Okay, now clearing everything off, what angle are we talking about here? Okay? Now, we're going to start in this positive area where both our x and our y value for our point are positive. Okay, this is what we've been dealing with so far with all of our triangles, all the practice we've done with SOHCAHTOA, sine, cosine, tangent. Everything's been a distance, a length, it's been positive. Okay, so we're going to start from here. We're going to start with the angle being 0. So we start here at 0 degrees, where this angle theta measures 0 degrees. Okay, so there is no angle. This top side and this bottom side overlap right here at 0 degrees. Now we can make this larger to where it's maybe 10, 20, 45, 60, 80, and then finally we get to a right angle, and up here is 90 degrees. Okay, this is our entire life so far in the sine, cosine, tangent, and trigonometry has been dealt in this one quadrant. Okay, a quadrant means a quarter of the coordinate plane. Okay, it's broken up into 4 quarters, and so we've been dealing with this top right first quadrant, right? But now we're going to expand it. We're going to say you can take this point here, and you can move this point further than 90 degrees, and just keep going, right? You can go to 100 degrees. You can go to 120, 130, 150, 170, and finally you get to 90 plus 90. A straight line is 180 degrees. Okay? And again, you could just keep going. 190, 200, 210, and so on until you do another 90 degrees. And down here, you get 270 degrees. And again, you keep going, you bring that point further and further and further until you make a full circle and you get back to here at 360 degrees. And this point can be represented by both 0 and 360 degrees. If you take any sine, cosine, tangent value of 0, it will be the exact same as if you take a sine, cosine, tangent value of 360 degrees, because you've gone literally full circle and you are now in the same place that you were at the beginning. Okay? Now vice versa, you could go the opposite direction. You could have started at 0 degrees and gone the other direction with the point. And so at 270 you could also have negative 90 degrees. And if you kept going, negative 180 degrees. And if you kept going, negative 270 degrees. And if you kept going, negative 360 degrees. Okay, so are you starting to see that you can continue to go in circle after circle after circle, and you keep hitting those same points over and over again? So at 0, it could be represented by a different angle, say 360 degrees. Or if you go in another circle, add another 360. This is the same as 720 degrees. Or add another 360, add another circle, right? It doesn't matter if you do 4 circles, 5 circles, 6 circles. You can keep adding 360, and the same point here, the same sine, cosine, tangent values will show up under 1080 degrees. Okay. All right, so those are the basics. Okay. The one other thing I'd like to introduce before we get started, and we'll do some practice problems together, is the reference angle. Because everything will basically come down to you taking a big number, maybe, the sine of 440 degrees, spinning around in a couple circles, finding where on the circle that point is. Okay, actually, let's take 440 degrees, for example. Okay, so if we started at 0 degrees, and we wanted to figure out where 440 was, we would say, okay, let's go all the way around in the positive direction, 180, 270, 360. Oh, we still got to keep going. Another 90 after 360 would take us to 450. So we've gone a little too far. We want to go 10 less than that. So here is our side, okay, and hitting a point right here. Okay, so our triangle that we would draw is right here. Sorry, it's a little sloppy. Okay, where we have 10 degrees here, 80 degrees here, and 10 degrees here. Whew, that's sloppy. I'm going to make that just a little bit bigger off to the side. So we are left with this triangle, okay, where this is an 80 and this is a 10, right? Now, pay close attention to where I put that. As we've been dealing with word problems in the past and we've been dealing with angle of elevation and angle of depression, I've stressed that we deal with horizontals. Okay, every once in a while it might say in a word problem from the vertical 10 degrees. That's very rare. For the most part, when we're dealing with angles in trigonometry, we're going to be dealing with horizontals. That's going to be emphasized here again. The reference angle always is the angle between your line connecting the center and your point. Okay, so this line, what is its angle of elevation or its angle of depression from the horizontal line? Okay, so I could put a point. I'm just going to clear this off. So I can put a point in any of the 4 quadrants, and just to label those, this is the first quadrant. We use Roman numerals. This is the second quadrant, and it just goes in order as I start from 0, go to 90, and I go in that counterclockwise direction to 180. The next quadrant we get to is the third, and then we hit 270, and then the next quadrant we get to is the fourth. Right? So I could draw a point in any of those 4. Right? And I just kind of make it in the middle so my triangle's nice and easy to see. Okay, but it could be anywhere in these 4 quadrants. Right? So for each of these points, we draw a right triangle down to the horizontal. Okay, down to the horizontal. Down to the horizontal. Down to the horizontal. Okay, got it. All right. Now what we're referring to as the reference angle is that angle of elevation or angle of depression in each of these. Okay, this angle is your reference angle. And as I mentioned when we were doing 30, 60, 90 triangles and 45, 45, 90 triangles, is all the values as you move forward in math that you'll be expected to know without a calculator come down to those 2 triangles and 4 points. So if you just remember your 30, 60, 90 triangle, your 45, 45, 90, and you learn these 4 important points at 0, 180, 90, and 270. That's every value you will be expected to know. Now, they might hide it behind what is the sine of 330 degrees, but you would spin around in circles and find, oh my gosh, the reference angle, in other words, the angle of elevation or angle of depression there, is just 30 degrees. Okay? And that angle to the horizontal, regardless of which quadrant you're in, how many times you've spun around in a circle, that's what you take the sine or the cosine of. Now, the one little caveat there is you need to pay attention to your positives and negatives. That won't come up on tonight's homework. We'll wait to introduce that. Today, we're just going to deal with finding where angles go, finding the reference angle, and then if I give you a picture, being able to identify what angle is that. So working forwards and backwards from the angle to the picture and from the picture back to the angle. Okay? Alright, so let's do a couple examples. Okay, so some straightforward examples. They might just ask you, find a quadrant where these lie. So we're going to sketch it very quickly. We say, okay, here's my plane. The first one, 330 degrees. It's in a positive direction, so we start at 0. We go to 90. We go to 180. We go to 270. But we don't quite make it to 360 again, right? We're 30 short. So if it had asked for you to draw this, it would look like this. You would label it 30 degrees. However, the question here just asks, what quadrant was this in? So if you spin around as you get close to 360, you stop 30 short, and so you're in the 1, 2, 3, 4, except we write it in Roman numerals. So we're in the 4th quadrant. Okay? All right. Over here, negative 210. So we say, okay, well, we're going in the negative direction. So starting at 0, we go negative 90, negative 180, and we go just a little bit further. In fact, 30 past it. So here it is, 30 degrees. That's a great sketch. We found our reference angle, but all we care about is which quadrant. So starting in 1, 2, 3, 4, we go up. With Roman numerals, we are in the second quadrant. Great. Okay. Alright, the other really common type of problem you're going to get is something like this, where it either gives you a picture and asks you to find the angle, or in this case gives you the angle and asks you to give the picture and find the reference angle. Okay, so let's start with the first one. We're going to draw a unit circle and say, wait a second, that's bigger than 360 degrees. Let's just go away and just as scratch work to help us out, let's just take away 360. Now if we take away 360, we're left with 240. We go, that's going to come in handy. Okay, so we start in the positive direction. We go around to 90, 180, 270, full 360. And we keep going another 240 degrees, so 90, 180, and not quite to 270. So after 180, we go another 60 more, or 30 short of 270. So this angle here is 60 degrees. Okay, so it's reference angle. The angle from the horizontal here is 60 degrees. Okay. Over here in the other one, we say, okay, well, it's less than 360, so I don't need to subtract anything. That was just helpful for me. Okay. So we're going negative direction here. So let's start. We go, okay, we go negative 90, 180, and these numbers should just be committed to memory, 90, 180, and 270. They're easy intervals, right? And you keep going to 270, and we go further, but we don't make it to 360. So we stop in here, okay, and now we could subtract. Okay, and to find out the reference angle, we can just write the 315 degrees minus the 270 that we just passed here. And so what we get is 45. And so that leaves us 45 here and 45 here. And so we get a reference angle here of 45 degrees from the horizontal. Alright, so you get your homework tomorrow and you'll see these types of problems and we'll talk about it in class. If you have any questions, you can email me or ask me in class. Good luck.